6th International Physics Olympiad year 1972 IPHO. Problem number 1. 3 cylinders with the same mass, the same length, and the same external radius are initially resting on an inclined plane. The coefficient of sliding friction on the inclined plane mu is known and has the same value for all the cylinders. The first cylinder is empty tube. The second is a homogeneous field, and the third has a cavity exactly like the first, but closed with 2 negligible mass leads and filled with liquid with the same density like the cylinder's walls. The friction between the liquid and the cylinder wall is considered negligible. The density of the material of the first cylinder is n times greater than that of the second or of the third cylinder. Determine A. The linear acceleration of the cylinders in the non-sliding case. Compare all the accelerations. B. Condition for angle alpha of the inclined plane so that no cylinders is sliding. C. Reciprocal ratios of the angular accelerations in the case of rollover with the sliding of all the 3 cylinders. Make a comparison between these accelerations. D. The interaction force between the liquid and the walls of the cylinder in the case of sliding of this cylinder, known that the liquid mass is ml. 6th International Physics Olympiad year 1972 IPHO. Problem number 2. 2 cylinders A and B with the equal diameters have inside 2 pistons with the negligible mass connected by a rigid rod. The pistons can move freely. The rod is a short tube with a valve. The valve is initially closed. The cylinder A and his piston is adiabatically insulated, and the cylinder B is in thermal contact with the thermostat, which has the temperature theta equal 27 degrees Celsius. Initially the piston of the cylinder A is fixed, and inside there is a mass M equal 32 kg of argon at a pressure higher than the atmospheric pressure. Inside the cylinder B there is a mass of oxygen at the normal atmospheric pressure. Liberating the piston of the cylinder A, it moves slowly enough, quasi-static, and at equilibrium the volume of the gas is 8 times higher, and in the cylinder B, the oxygen's density increased 2 times. Knowing that the thermostat received the heat Q prime equal 747.9 by 10 power 4 joules, determine A. Established on the base of the kinetic theory of the gases, studying the elastic collisions of the molecules with the piston, that the thermal equation of the process taking place in the cylinder A is T multiplied by V power 2/3 equal constant. Question B. Calculate the parameters P, V, and T of argon in the initial and the final states. Question C. Opening the valve which separates the 2 cylinders, calculate the final pressure of the mixture of the gases. The kilomolar mass of argon is mu equal 40 kg per kilomole. 6th International Physics Olympiad, year 1972, IPHO. Problem number 3. A plane capacitor with rectangular plates is fixed in a vertical position, having the lower part in contact with the dielectric liquid. Determine the height h of the liquid between the plates and explain the phenomenon. The capillarity effects are neglected. It is supposed that the distance between the plates is much smaller than the linear dimensions of the plates. It is known the initial intensity of the electric field of the charged capacitor E, the density ρ, the relative electric permittivity epsilon r of the liquid, and the height big H of the plates of the capacitor. 6th International Physics Olympiad, year 1972, IPHO. Problem number 4. A thin lens plane convex with the diameter 2 small r, the curvature radius big R, and the refractive index n0 is positioned so that on its left side is air, n1 equal 1, and on its right side there is a transparent medium with the refractive index n2 not equal to 1. The convex face of the lens is directed towards air. In the air, at the distance s1 from the lens measured on the principal optic axis, there is a punctual source of monochromatic light. Question A. Demonstrate using Gauss approximation that between the position of the image given by the distance s2 from the lens and the position of the light source exists the relation f1 over s1 plus f2 over s2 equal 1, where f1 and f2 are the focal distances of the lens in air, respectively, in the medium with the refractive index n2. Observation. All the refractive indexes are absolute indexes. Question B. The lens is cut perpendicular on its plane face in two equal parts. These parts are moved away at a distance delta much less than r. Billet lens. On the symmetry axis of the system obtained is LED, a punctual source of light at the distance s1 greater than f1. On the right side of the lens there is a screen E at the distance d. The screen is parallel with the plane face of the lens. On this screen there are n interference fringes if on the right side of the lens is air. Determine n function of the wavelength.